Now let's take a look at some more examples using trig substitution. Starting with the integral of 1 over x squared times the root of 16x squared minus 9. Now if we're going to use trig substitution, the standard type of form that we looked at were things like root of x squared minus a squared. Here you have this factor 16 in front of x squared inside the root that is in the way in some sense, so I'm going to factor it out. So if I factor 16 out, I'm going to pull this 16 out of the root. That's going to be a 4. And so I have 1/4 coming out of the integral. And then inside my root I have x squared minus 9 over 16. So now I'm going to use trig substitution. And I have to use a trig substitution that corresponds to the last row, because we have a root of the form x squared minus a squared. In that case, we have to use a substitution of the type x equal a secant of theta and pick one of the intervals depending on whether secant, which corresponds to x over a, is greater than 1 or less than 1. So here we're going to take theta between 0 and pi over 2, which corresponds to x over a greater than 1. So in our case, a is the root of 9 over 16, in other words 3/4. So we set x equal to 3/4 of secant of theta for theta between 0 and pi over 2, strictly less than pi over 2, which corresponds to x over a greater than 1, in other words x greater than 3/4. So in other words, we're going to look for an antiderivative of the function 1 over x squared root of 16x squared minus 9 on the interval 3/4 to infinity. So now, if x is 3/4 of secant theta, then dx is 3/4 of the derivative of secant. Secant is 1 over cosine, so the derivative is negative derivative of cosine, which is positive sine, divided by cosine squared. So I have 1/4 in front of my integral. I can pull out the 3/4 from the dx, so I have 1/4 of 3/4 of the integral of what corresponds to dx, so sine theta over cosine square theta. And at the bottom I have x squared, which is the square of 3/4 secant, in other words 9/16 of secant square theta. And then root of x squared minus 9/16, which is 9/16 of secant square theta minus 9/16, and I can factor out my 9/16. So this 1/4 of 3/4 is 3/16, and it's divided by 9/16, so I get 3/9, which is just 1/3. And then in my integral here I have sine theta over cosine square theta, that's really sine theta multiplied by secant square theta. That is divided by secant squared, so the 1 over cosine square at the top and secant square at the bottom cancel out. And I end up with just sine theta at the top and my root at the bottom. I can pull out 9/16 out of the root, and that gives me 3/4 outside of the root. And then this secant square theta minus 1 is really just tangent squared. That's why we're using this trig substitution, because of this identity. And so we obtain 1/3 integral of sine theta divided by this 3/4 when I pulled 9/16 out of the root, times root of tangent square theta. But we have picked theta to be between 0 and pi over 2. In other words, we're looking for an antiderivative on the interval 3/4 to infinity for x. And that means that tangent theta is positive, and therefore square root of tangent square theta is really tangent theta. So 1/3 over 3/4 is really just 4. And so we have 4 integral of sine theta divided by tangent theta. But tangent is really sine over cosine, so that simplifies as 4 integral of cosine theta. The antiderivative of cosine theta is just sine theta, so we end up with 4 sine theta plus c. Now we want an antiderivative in terms of x, so we go back at what x is. X is 3/4 of secant. That means 4x over 3 is secant, which is 1 over cosine. Okay, that means that cosine is 3 over 4x, and that's also the ratio of the adjacent side to the hypotenuse. So we can represent this situation in this triangle where the adjacent side has length 3, the hypotenuse has length 4x, and using the Pythagorean theorem, the missing side of the triangle has length root of 16x squared minus 9, which is of course the root that appears in our integral. So now I'm looking for sine of theta. This is the opposite side, root of 16x squared minus 9, divided by the hypotenuse for x. So I end up with 4 multiplied by root of 16x squared minus 9 divided by 4x. The 4 cancels out, and again this gives me an antiderivative of the function 1 over x squared root of 16x squared minus 9 on the interval x greater or equal to 3/4. Now let's look at a somewhat different kind of example. We don't have a root in this one, but we're trying to integrate 1 over x squared plus 4 squared. Without the square, we would know what to do because we know that an antiderivative of 1 over x squared plus 4 is 1/2 arctangent of x over 2. However, with this square, it's a little bit harder to see what to do. So one thing that we can try is use what we use to get rid of a root. After all, what we do is just write the sum of square or difference of squares as one square, so that with the root something cancels out. Here, if I write this x squared plus 4 as a square of something, then I square that, I get just the power of something. Hopefully I can get that as a new variable and have things working out. So let's see what we get if we try to do that. So we're going to use, of course, what we would use to transform a squared plus x squared into a square, in other words this row, and that means that we're going to take x equal a tangent theta. In our case, a of course is 2, so we take x is 2 tangent theta, where theta is restricted to negative pi over 2 to pi over 2. dx in that case is 2 times the derivative of tangent, which is 2 secant squared theta, d theta. So I replace dx by this quantity and x squared by 4 tangent squared theta, and this is what I obtain. At the bottom I'm going to factor out 4, so I have 4 tangent squared theta plus 1, and when I pull the 4 out of the square I get a 16. Pulling the 2 from the top out, I get 2 over 16, and then integral of secant squared theta divided by tangent squared theta plus 1 squared. The whole point of using this trig substitution is to use the fact that 1 plus tangent squared is secant squared. So we just replace tangent squared theta plus 1 by secant squared. When it's squared, it gives me secant to the 4th. So you have secant squared at the top, secant to the 4th at the bottom, simplifies as 1 over secant squared. But secant is really the reciprocal of cosine, so 1 over secant squared is really just cosine squared. So I obtain 1/8 of the integral of cosine squared. And we know how to integrate that. This is something that we studied earlier in this module. This is an even power of a trig function. We know what to do. We use a double angle formula. Namely that cosine square of theta is cosine of twice the angle theta plus 1 all this over 2. So making this substitution, pulling out the 1/2, we get 1/16 integral of cosine 2 theta plus 1. And an antiderivative of cosine 2 theta is simply 1/2 of sine 2 theta. So when I multiply by 1/16, I get 1 over 32 sine of 2 theta. And then an antiderivative of 1 is simply theta, multiplied by 1/16, so I get theta over 16. Now to get back to a function of x, it's going to be simpler to re-express sine of 2 theta in terms of sine theta and cosine theta, because we have a more straightforward relationship between trig functions of theta and x. So the other part, the second half of the double angle formula, is that sine of twice an angle is 2 times the product of sine and cosine of the angle. So that means I can replace sine 2 theta by 2 sine theta cosine theta, and this 2 over 32 gives me 1/16. So now I'm going to factor out this 1/16, It's multiplied by the product of sine theta and cosine theta, and plus theta. And now I'm in a position to re-express this in terms of x using the usual geometric interpretation in the triangle. We have x is 2 tangent theta, in other words tangent theta is x over 2, and tangent is really the ratio of the opposite to the adjacent side. On the other hand, since theta is restricted to negative pi over 2 to pi over 2, that means that theta is arctangent of x over 2. And in our triangle, we have this ratio of opposite to adjacent side, which is x to 2. And using the Pythagorean theorem in this triangle, the missing side has length square root of x squared plus 4. Therefore, sine of theta is the opposite side of our hypotenuse, so x over root of x squared plus 4, and cosine is the adjacent side, 2 over the hypotenuse root of x squared plus 4. So when I multiply them together, I get 2x over the square root squared. In other words, I get 2x over x squared plus 4. So I have 1/16 of 2x over x squared plus 4 plus theta, which is arctangent x over 2. All this up to a constant. So that gives you enough examples to now turn to the homework for you to train.